In this video, let us focus on a question from JEST 2021. Here we have a question about a rigid body. A rigid body, as you know, is a body in which distance between any two points remains constant. So if you apply force or torque, even then the distance between any two points is not going to change. It is not going to deform. It is going to maintain its shape and size whatever you do to it. So this is an idealized object, because in reality you know that if we apply force or torque, the body can change its shape and size. Mathematically we can write it like this. If the position vector of point A is xa and position vector of point B is xb, then modulus of it is equal to constant. Mathematically, this is how we represent a rigid body. Now, since xa minus xb modulus is equal to constant, I can write xa minus xb modulus square is also equal to constant. You also know that modulus of a square can be written as a dot a. Vector a dot vector a is equal to modulus of a square. Therefore, we can write xa minus xb modulus square is equal to xa minus xb modulus square. This is equal to xa minus xb dot xa minus xb. All of these are vectors, and we are saying that this is equal to constant for rigid body. Now let us take the derivative of this relation with respect to time. So differentiate with respect to time. Then you can apply product rule in the LHS. First take derivative of red, then multiply by blue, and then take derivative with respect to blue, and then multiply by red, add them. So you will get xa dot, this dot represents time derivative, minus xb dot times, here is a dot product, xa minus xb. Now when you take derivative of blue, you will get the same thing, xa dot minus xb dot, and then you multiply with red, which is xa minus xb. So this is actually 2 times and equal to 0. We can dissolve 2 also in 0. Therefore we have xa dot minus xb dot xa minus xb is equal to 0. Now differentiate again with respect to time. Differentiate again. Then you will get again product rule, xa double dot minus xb double dot dot xa minus xb plus xa dot minus xb dot as it is, and now take derivative of second term, which is xa dot minus xb dot. This is equal to 0. Now this can be written as modulus of xa dot minus xb dot square, and remaining we have xa double dot minus xb double dot xa minus xb. So this is the correct relation for a rigid body. xa double dot minus xb double dot xa minus xb plus xa dot minus xb dot modulus square is equal to 0. Therefore the correct option here is option C.